So remember, everything with an aqueous symbol gets separated. All right, and everything without an aqueous symbol, like a solid, a liquid, or a gas, would not get separated. So the lead iodide won't separate when you're writing out the ionic equation. So when you're doing this, you have to remember what pieces there were that put it together. So when it says 2Ki, what that's saying is there's Ki and Ki. And when it says PbNO3 that means there's Pb, and it's connected to 2 of the NO3s. Come on. All right. And then on the other side, when it says 2KNO3, that means there's KNO3 and another KNO3. And then the PbI2 just stays PbI2, so I don't have to worry about that too much. So this is going to tell me what to do as far as coefficients in the ionic equation. So down. If potassium iodide breaks into parts, I'm going to have 2 potassiums. And I'm going to have 2 iodides. All right, and that's not 21, that's 2I. All right, so what about the lead? How many lead will I have? So if the lead's separated from the nitrates, how many lead would I have? 1. Good. All right. And the last part for the left side is to figure out how many nitrates would I have. How many nitrate would I have? If lead separated from the nitrate. How many nitrate would be floating around? Correct, 2. Because what's going to happen is this bond here and this bond here are going to, separate because it's ionic, and we'll just have a nitrate, and a lead, and they'll be separate and they'll be floating around. And so that means that I put 2 NO3 minus like that. So you see how where I had the 2 as the coefficient for Ki, which was right here, do you see that that became a 2 here and a 2 here? Now with the lead, there was no coefficient. So that didn't do anything, right? So then I had to look at the pieces. And I know lead is one piece and nitrate is another piece. So as far as ionic compounds, I have to break it into the different ions. And it says NO3 2. That tells me that I'm going to have 2 of the nitrates. They're not connected to anything, so I'm going to put it as a coefficient. Because when you have a coefficient, it's telling how many of them you have, but when you have a subscript, it's telling you how many of them are bonded to something. All right, so let's take a look at what happens on the right-hand side. All right, so on the right-hand side, you see the blue arrow. The only thing that's going to fall apart is the potassium and the nitrate. So when it says 2KNO3, that means there is a KNO3 and another KNO3. Right, and they're both aqueous. And then the other thing we have is a PbI2 solid. Now we can go ahead and write down the PbI2 solid because that doesn't fall apart. So when I look at this now and I have 2 potassium nitrates, what's the coefficient for the potassium?
2.
2. Good. All right. And what's going to be the coefficient for the nitrate? Yes, that would be 2 also. All right, so you can see what happened on this side. So since this had a solid, that means it doesn't separate, and we see that it's not separated right there. You mean the nitrate? Yes, it would be NO3 minus.
Oh.
You are correct. I need to put a minus symbol there. I missed that. So that would, we'll just imagine that it's down there. Okay, so NO3 minus, you are correct. All right. And then with the potassium nitrate, we have this 2 right here. And that causes there to be a 2 in front of the potassium and a 2 in front of the nitrate. Does that make sense so far? Oh, did I put... Yes, I should also have a minus. I don't know why I'm leaving off charges. All right. So that's 2K plus, 2I minus, Pb2 plus, NO3 minus, PbI2K plus, NO3 minus. Okay. All right. So figuring out the coefficients seems kind of hard, but it's not really hard. You just have to figure out how they're connected and take apart all the aqueous things into their ions. And if they have polyatomic ions, keep the polyatomic ion together, but separate it from whatever else it's connected to. So for example, with the potassium nitrate, we kept nitrate together, but we did separate it from the potassium. All right, and to get to the net ionic equation, again, we're going to cross out all of the spectator ions. So potassium over here, potassium over here, nitrate over here, nitrate over here, and then for the net ionic equation, you write whatever's left over. All right, and so that would be the net ionic equation. There is a shortcut to finding the spectator ions and finding the net ionic equation. And the method to do that is search in there on the right-hand side and see if anything is not aqueous. Right? This is not aqueous. Right? So that's going to be our product in the ionic equation. Then we want to look and see what made it, and it was made from lead and 2 iodide. If you look over here, you'll see we had a lead and 2 iodide. And that's all you have to figure out for the net ionic equation. This is a nice way to cut down on test time when it's asking whether or not something is, like which of the following is the net ionic equation. Then you would just look at the product that's not aqueous and then separate it into its ions. Now, if you were trying to find spectator ions, the first thing you're going to do again is you're going to find whatever's solid. Actually, you could find whatever was aqueous. That would make more sense. All right, so we're going to find whatever's aqueous. Right? This is the only aqueous thing on the right-hand side. The ions that make up potassium nitrate are potassium and nitrate. Those are the spectator ions. So that should cut down on your work a lot. So to find the net ionic equation, it's the stuff that's solid. You separate it out into its ions. Done. Figure out what the spectator ions are. You just look on the right-hand side of the arrow. Anything with an aqueous symbol, whatever ions made up, those are the spectator ions. Any questions about that?